Hello, welcome back to another video. We'll continue our series of learning Zig in an attempt to understand and get better at systems programming. For those of you who haven't seen my previous videos, I'm essentially trying to learn the Zig programming language by following the Ziglings, which is a fun exercise project by Chris Bosch, and we made decent headway solving these fun little programs that teach us fundamental concepts of Zig. So without much ado, let's get started on the next exercise. Yep, so previously we looked at errors. We did a couple of exercises, we looked at functions, we looked at errors, we looked at return types and how errors play, we looked at error unions. Essentially, we understood how error as a value type works, its importance and benefits when we're writing a language like Zig. Today, let's continue the progress into more Zig concepts. Cool. Great news. Now we know enough to understand a real Hello World program in Zig, one that uses a system standard out resource which can fail. Yep. Yes, previous programs we were under the assumption that whatever we're outputting will not fail. Going forward, since we have an understanding of errors work, we know that most things are not guaranteed to succeed, and we have to account for errors, whether it's transient or otherwise. Cool. We have the standard function. Now take a note that this main function now returns void preceded by an exclamation mark rather than just void. Since there's no specific error type, this means that Zig will infer the error type. Okay. This is appropriate in the case of main, but can make a function harder or even impossible to work with recursion in some cases. Okay, makes sense. In the main function, we will say there is an error, but we don't have to specify the type. Again, it's the first function that's called. So say we don't have an error type, fine, it's the very first function, the compiler will know. But I don't think we should ever do that for non-main functions or any other regular function. Makes sense. Cool. Now let's look at I/O. Instance of the input-output operations. We will learn more about this later. Cool. I was about to jump into the Zig website and look it up, but no, we'll trust the process. We do not want too many tangents. Every now and then, fine. To satisfy the curiosity, we'll do it. For now, let's assume it. But if I do hover over it, it looks like it's init is standard process init. Is it a type? Okay, it's a structure. Cool. We haven't actually come across structures yet. I'm sure it'll be in one of the exercises very soon. Yep, exercise 37. Cool. Now we're gonna assign it I/O, which seems like it's a type of its own. Cool. Let's keep going. We get a writer for standard out. Cool. So we have a standard output writer. So we'll say standard library.io. Okay, this is a different. Okay, IO library std. I wonder why IO is capital and std isn't. Yeah, because this is the library that we imported. That's fine. That's a variable, and within this, IO is another. At this innermost struct. It's a type. Types are all marked. Okay, cool. So the standard IO and there's a file, probably a struct again, right? Okay, this keyword innermost structure union this that this function call is inside. This can be useful for, okay, we'll just go on. But we do get the idea of what's happening here. We're essentially trying to write something to the standard output, and we're saying one of the writers will be init.input output. So we can either write to a file, or we can write, we can pass in a file, we can pass IO, we can pass in a buffer. And that returns a returns a writer. Okay, I think it makes sense. And it's extracted its interface, so we can print to it and extract its interface. Okay, so this will create a writer. We'll dig deeper a bit later once we understand structs. Essentially, in the writer, we are extracting its interface so we can print to it. I did not understand why we're doing an ampersand. Are we passing its reference now of the interface? Looks like it, because usually if it's the ampersand, it's the reference to this interface, standard out, and now we can print it. If I get this right, from the standard library, there's again a file, we call it library. I'm just going to call it a library for now because it seems to be defined in a separate file. It's sort of like a namespace almost. And we have a standard out function which returns a file. And file has the writer function then. This is coming from this. Okay, I want to understand some of this more, but looks like we're initializing the writer. But there's no classes here, it's not object oriented. But it is initializing a type writer or returning it. Cool. Standard out will return a file. And then we'll call in a writer. Cool. This will return a writer. What's the return type of this? Returning a function on function. Never mind, my bad, sorry. It's returning a writer type. And the writer type has access to an interface which we are passing by reference, and now this will be a pointer. The pointer will call the actual method print, and we're displaying it. Unlike debug, the standard output can fail because the file may not exist, the file permissions might not be there. Anyway, let's just run this. We'll trust it. We'll circle back to it. My bad. Okay, we have an error. Error union is ignored. Yes. When we are printing something, an error can occur. Okay. We don't care what the error is. We want to be able to pass it as a return value of main. Cool. If an error occurs here, it can be of type error or void. Can we just say try? Either it works or something fails, the shorthand will take over. I believe that is sufficient. Let me clear the output here. Yep, that works. It kind of makes sense. I'm a little wonky on this aspect, the way it's written. I understand what's happening here, but I want to understand. This is the standard library assigned to a constant. What is IO? It seems like it's another constant, but there's this keyword, and if we also search the IO, again, it seems like there is this definition assigned to it, like IO. there a new or something like that? I saw some reference to it that I kind of found interesting. Okay, we have a whole bunch of imports. Yeah, I want to understand this. Essentially, from IO, is there a file here? No, this is imported. What are they trying to do? They're trying to break it into smaller nested libraries that they're then importing. And this is more like a namespace in C#, the whole file is called file. Could be. And stdout is a function that's defined in this namespace. Very much so. It seems like it. That's okay. We'll circle back to it when the time comes. I'm sure we'll have a long, slow journey into understanding systems programming, particularly Zig. Cool. I think it makes sense. Pretty straightforward exercise based on our on the previous learnings on errors. This is just a shorthand for it. I guess just for learning's sake, we can also write more expressive syntax with catch, and we'll say ERR, and we'll say return ERR. I believe that will also execute the same output. Hence, we have written a safer implementation that handles errors. Cool. Let's go more on to the next one. The defer keyword. Okay. I used this. I've used a couple of things. One, I've used the yield keyword in C#, but I don't think those two are even remotely the same. But I have used the deferred keyword while learning a bit of Go. No, I haven't gone too in depth into the Go programming language. I did read a bit about it to get a good feel of what the language is like, but I want to go a lot more further in Zig. But I think I get the idea. For example, in Go, you open a file buffer, and then you can defer the closing. Essentially, you don't have to put the defer code at the bottom at the very end before the file buffer goes out of scope. You can do it right next, but if you have the defer keyword, up until the file variable to which the buffer was assigned is in scope, the defer will not call. But when it goes out of scope, defer is going to get called, and it'll do a lot of cleanup stuff. Cool, that makes sense. In the above example, run later. So we have a defer keyword and run now. We can assign some code to run after a block of code exists. Yep, this makes sense. The second it goes out of scope of this, it's going to run this. So run now will run, and run later will run later. An example run, yeah, essentially this is what's going to happen. Makes a ton of sense. The feature seems strange at first, but we'll see how it could be useful in the next exercise. Cool, we have the main function. Without changing anything else, please add a defer statement to this code so that our program prints 1 and then 2. Before we do that, let me run it directly to prove that it's actually going to print 2, 1. Perfect. We have 2 and we have 1, and this is nothing but just the cursor character showing up, the prompt character. Let me do this so that it's a little bit more clear. I guess I could have done it right here. Oh, I know why they haven't done it. Never mind. Because they want 1 and 2 to show up next to each other. Cool. Let me add the defer here. This will make sure that first print is going to get executed, and then this will only get executed right before main function scope is ending. It should show 1, 2, and then a new line. Perfect. This kind of makes sense. Pretty straightforward. Defer essentially, it's a language syntax that makes it easier to write code that needs to to do some cleanup sort of operation or some sort of an operation right before the body of the function is going out of scope. Makes a ton of sense. Yeah, in C# we also have something called as usings, where we can scope certain things to be created and destroyed once the scope is eliminated. Cool. Now let's take a look at the main function. We have an array of animals where, actually let's read this. Now that you know how defer works, let's do something more interesting with it. Cool. We have the standard library, main function, an array of animals, which seems to be characters, an array of characters, or more precisely, as precision is something that Zig values, it's an array of bytes. We happen to be assigning characters. Now for animals, for each animal, we're just going to print its character. Study debug print done. Cool. Once all of this is done, we're going to print the keyword done and then add in a new line. Cool. The function is supposed to print an animal name in parentheses. Yep. It's supposed to print the animal name in parentheses like goat, but we somehow need to print the end parentheses, even though this function can return in 4 different places. Opening is straightforward. How do we do the closing? I get the idea already. Cool. Amazing. Print animal makes sense for each character that's passed in. We do have an if conditional checks here that print in if it's G, it's pre-printed goat, C is cat. It's just a dummy example. Usually code is never written like this. I should say never. I should say it never should be written like this. Cool, let's just run it first before we change. Yep, it looks like we're opening and closing, and then for each of the print animals we're doing it. Again, it doesn't make sense. A smarter way to do it would be for each of the animal, let it open at first. What we then want to do is to write the defer keyword here. That way, after whatever is going to be printed here, or here, or here, or here, later on, the closing parenthesis is applied, because this defer, I think, makes it run right before this is going out of scope. Let's see that in action. Perfect. We have goat, cat, dog, goat, and unknown. Perfect. So we saw one of the good use cases of defer. This is one among many other advantages that something like the defer construct provides us. Makes sense, pretty straightforward. I think there's not much to it other than it's a pretty handy tool to have. Cool. Let's jump in. Let's go on to the next one. Error defer. Another common problem is a block of code that could exit in multiple places due to an error, but that needs to do something before it exits, typically clean up after itself. An error is defer that only runs if the block exits with an error. An error defer. Oh, okay. Very, very interesting. It's almost like a finally block. Never mind. Finally will always execute irrespective, like, okay, for those of you who might be confused as to what I'm blabbering about, say in languages, object-oriented languages, C# or Java, you'll have your try brought, you'll have your catch block. We'll just say at some exception, ex log or do something with the error. This is the original intended action or actions, and we have the finally block. However, The caveat here is in the finally block always get executed irrespective of whether an error occurs or not. I believe error diff is similar to a catch block more than it is to a finally block, right? Only if the try statement returns an error produced by can fail. Yep. Yep, that kind of makes sense because it's trying to say that within the try, you can have catches, but for whatever reason we cannot catch or compare the type of the error and do an operation, and we're just returning whatever error that occurred, even in the catch, which is this is the shorthand for that. In that case, this particular function runs. Error defer only runs if this enclosing block exits due to an error. Understandable. That means that we don't have to have the function, the cleanup, and the catch. Yep. So we import the standard library. Cleanup is only called only the try. Yep. Returns an error, understandable. We have a counter and we have a my error type here. Cool. Now we have the public function. Main function, we have two different constants. One is make a number or catch, and we're returning. It returns void. So if an error occurs, it swallows it essentially. Makes sense. We simply quit the entire program if we can fail to get a number. Yes, essentially it is a quit, but we're sort of swallowing the error. We're just terminating the flow of control of the program to its caller, but in the main function, the caller is nothing but the execution environment that invokes it. Now says, hey, we're done. Cool. We also have a debug statement here where we're printing the values of A and B, and this would only run again if both A and B's invocation of make number works. Cool. And make number, we have a simple debug print trying to get a number, and we also print, oh, failed. Please make the failed message print only if the make number function exits with an error. We already know how to do this. Error defer is the answer pretty much, but let's see how it works with or without it. Now we have try get number. This could fail. I could fail, but I don't. Okay, we're simulating something that could fail, but it doesn't. And then we have try increase number. This could also fail. Trying to return an error explicitly here. Okay. Yeah, we're just trying to simulate here something that could fail, but never ever fails. Never ever fails because we see the code here, but based on the return type, it potentially could fail. That's another thing. It's a valid return type, even though no error is being returned. Curious though. I was hoping Zig would somehow block it and say, hey, you find an error type, but I don't see a single error being returned, but looks like Zig accepts it. Makes sense. Probably a reason the people who designed the language are significantly smarter than what I am. There must be a reason, and by doing 29 exercises, I do not want to challenge the incredibly smart people who built this language, but I do want to keep it at the back of my head so I can learn it and understand their reasoning and decision, because I think that's far more valuable than outright questioning why is it the way it is. Also got to think why not. Cool. We have the increase number function that does seem to be returning an error. Sneaky, weird global stuff. Interesting. The counter is actually here. We're almost trying to simulate a failure scenario that'll succeed the first time, because counter is not more than 0, but the second time it will fail. Okay, it's almost a controlled randomization. Like, we're trying to make it look like it randomly fails, but it's actually being controlled in the code. I understand. There's nothing too fancy here. It's just Chris Bosch or whoever wrote the exercise trying to help us understand by simulating certain conditions from happening, and they're just making it deterministic. That's all. Cool. Before we fix this, and the fix would be here to do, and so we want to do something like an error fix would be for this, but the actual fix I think we would be applying here, to only run when a failure occurs, instead of doing. Let me just run it first before I try all the fancy stuff. 029. Perfect. It's printing getting number and immediately prints failed, obviously, because it's one after the other, and it's sequential execution. And then let's see the next one. We're calling try increment function. It got 5 and it's saying got 5. And then we also see ... failed. Why is it printing ... failed? Because when we're doing try get first one I understand, because this is printing right after this. Now why is it printing failed right after this? That is interesting, isn't it? That's because got 5. How many times is this called? On the first one, getting number fails. Because on the first one we're calling the make number function. We're doing a get number for 4, and on 4 we're incrementing the number, count plus 1, return n plus 2, and then we have 5 here. Cool. When we call it again, since counter is global, it's defined outside any function and it's on the whole scope, it would have been changed to 1, and we do a get number again, and it's 1. Get number returns 4 again for number, and then when we go in here, the counter is now, irrespective of what is passed here, it's greater than 1, because in the previous iteration it was incremented. Global variable persists throughout the scope of the whole program, right? So now it fails, throws an error. An error is thrown here, which is nothing but a straight return. It comes here, and the program closes, right? I believe so. The second fail is what I'm trying to understand. Now I know the solution, what to do to ensure it doesn't happen here. Let's see where ... is coming from. That'll give us the clue, right? Getting number. Oh, never mind. I understand. Got 5 is just a value here. Yeah, we're returning got 5, and then we're returning a number. Number comes here. It's saved to 5. In the first make number function, we're printing getting number and failed. We run through it. In the second time we call it, the get number will return 4. Try increase number will fail. The second it fails, we're going to return whatever is passed in plus 1. Previously what we had passed in the n spot here would now be 4 plus 1, which is 5. And we printed 5, and then we return the number. Yep, a second time we call, errors out. But getting number and failed is immediately printed. And when we do this, cool. Did I follow the flow correctly? Yep, understood. This is printed for A. This is printed for B. Makes sense. Let's change this, shall we? Let's add in the error defer. This will only run now when an error occurs anywhere inside this. Give it a run. Perfect. First time we're calling it, it's saying we're getting a number, got 5. Second time we were calling it, we're getting a number, it failed. It failed because in the second time this counter is incremented to 1, and we know from this condition here, if it's 1, if anything greater than 0, it's going to immediately fail. It propagates up, we handle it, it propagates up. Flow of control just terminates the execution. Cool. I think we've got a good understanding that is very well tied with errors. I'm going to stop it here because we hit the 30-minute mark. Plus, I feel like my voice is going out today, to be honest. I was a little bit tired, but however, I wanted to write a little bit of Zig just to lift my spirits up. And I think it did a great job with that. Cool. In line with how we were building errors, this is a good progression into the hello program. Part 2 was a good introduction into how errors are expected and we need to keep in mind while writing any real world program. Then we read the defer keyword, how it helps with cleanup tasks and other things. And then we also saw error defer, which is a special case of defer that only runs when an error occurs in the block of the error defer. We do have things like this in other languages. Something that comes to mind, usings for an example, is very similar. It is scoped, but it does have its benefits in C#. Yeah, different languages have different construct. I, for one, clearly understood the spirit of Zig in this case. Yep, I think it's a good stopping point. Let me give another shout out again to the Zig programming language. Please go ahead, take a look at this. I'll give you my reasons of doing these exercises and learning. I really want to connect more through software interfaces into hardware, among other things. Even systems programming in general, like writing code, writing software that uses hardware to its full potential without a whole lot of runtime abstraction. Essentially, going back to the roots of programming. I find it to be fun. I personally am not doing this with any grand vision. I just want to do it for the fun of it. But one of my personal goals is systems programming. So Zig is for fun. I want to understand it and learn it. But I do want that fun to gradually encompass systems programming. Those are my reasons, irrespective of what any of you watching, what your reasons are. I would highly recommend this language. I find it fascinating. I'm not gonna give its pros or cons because I myself am learning more of it, but I find it fascinating and very interesting. So if you're interested, please hop in. I'll end it there, giving another shout out to Chris Bosch and Zigling. I'm incredibly grateful for this resource, and I just have to give it a shout out every video. Um, let's call it there. Thank you, everybody. See you all in another video. Bye.